Now this came in 2010. Okay, let the function f of x be minimum of the functions x comma x squared where x belongs to R. The function fx is continuous everywhere, continuous except 0 and 1, differentiable everywhere except 0 and 1. Now look, what two functions do we have? We have y equal to x, y equal to x squared. Correct? Y equal to x, y equal to x squared. And we know that y equal to x squared is always greater than or equal to 0. But not y equal to x. Now when they say minimum, we have now understood that for negative values of x, okay, for all negative values of x, it's not y equal to x squared that is going to be the function's definition. It's rather y equal to x. Correct? It's y equal to x because that's negative. And suppose this is that 1 comma 1 point where both the curves meet in the first quadrant. This is also y equal to x. Now why did I not draw this particular portion of it? I could have drawn it. But I know when it comes to y equal to x squared, and I think I have told you this many times, that when n is greater than 1, then x always remains greater than x raised to n for all values of x in between 0 and 1. Okay, for all values of x in the open interval 0 and 1. So be it x cube, x squared, x raised to 1.1, all of them will be below that. Okay, so this will be the parabola. Well, we can draw the symmetry by symmetry this portion also, but what will be the function's representation? The function's representation would be this line followed by this and then followed by this. Okay, now there is no doubt that this is continuous everywhere. Okay, this is continuous everywhere, so option A is right. Okay, I think this is a multiple select question. Now, is it differentiable everywhere? It's not differentiable everywhere. It is differentiable everywhere except two locations. Which two locations can we see now from the graph? X equal to 0. What is the right hand derivative? Right hand derivative is 2x at 0. That is 0. But what is the left hand derivative? It's a line, derivative of line. Well, y equal to x is constant, so that's 1. Unequal, so it's not differentiable at 0, and from the options we can easily conclude that it's also not differentiable at 1. Why is it not differentiable at 1? Again same logic. Look, at this point where x is 1, what is the left hand derivative? It is 2x at 1. That's 2. But what is the right hand derivative? 1. Are they equal? No, they are not equal. So it's not differentiable at 0 and 1. Everywhere else it is differentiable. Okay. Raise your hands if you have understood question 5. Right? And such questions can come in your IISc or even future nests also, because it will test everything. Graphs of functions, behavior of functions, limits, continuity, differentiability, everything. Okay, in some cases also periodicity. Okay?